Hi and welcome to my channel, High School Physics. This channel is designed for high school students who really need help with physics. In today's video, I am going to talk about charging and discharging of capacitor. First, let us look at charging. I'm going to consider a circuit that has a capacitor, a resistor that are connected in series across a power supply. So the voltage of the supply is Vs. We have the capacitor C and resistor R. The voltage that will be appearing across capacitor will be Vc. Across the resistor will be Vr. And because there is a supply, the current will start flowing. So as the current flows, the capacitor gets charged. So the equation from the circuit, we can see that it's Vs is equal to Vc plus Vr. Now during charging, what happens is Vc will increase. Vc increases. Because Vc is increasing, Vr decreases. As we know that Vr is equal to IR, because Vr decreases, I decreases. Now, if we have to graph the V versus T and I versus T to see like what is the charging curve, so this is V, T, I, and T. So charging is always exponential. You can see that after one point, it is going to be constant. And this is at tau. And the voltage is going to be Vc. This is the voltage of the capacitor. So what is tau? Tau is nothing but it's a time constant. Tau is time constant. So tau is equal to RC. And what is the curve for the current versus T? It's going to be a decay curve because the current is decreasing. So for the exponential curve, this is exponential. The expression is Vc is equal to Vs times 1 minus e power minus t over tau. When t is equal to tau, we have Vc is equal to Vs times 1 minus e power minus 1, or Vc is equal to Vs times 1 minus 0.37, because e power minus 1 is 0.37. So we have Vc is equal to 0.63 times Vs. And this is the expression for charging voltage of the capacitor. So it is 63% times the supply voltage. Now moving on with discharging of capacitor. Now, during discharging, what happens is the battery must be removed. If the battery is removed, what we have is the capacitor and a resistor. So the capacitor has to discharge. The capacitor will start discharging through the resistor. So this is the voltage VC. So the VC has to be discharged. So what happens is VC will be equal to VR. As VC decreases, VR decreases because VR is equal to IR. I also decreases. Now, let us take a look at the graph of V versus T and I versus T. So V is going to decrease, and this is the decay curve. And we saw even I is also going to decrease. So we have the I versus T graph here. This is VC. It's a decay curve. So decay curve has the expression VC is equal to e power minus T over tau Vs. So when T is equal to tau, we have Vc is equal to e power minus 1 times Vs, or Vc is equal to 0.37 times Vs. That means the decay is 37% of the supply voltage. All right. So this is the end of today's video. And in today's video, what I have discussed is about charging and discharging of the capacitor. And I've also shown you by means of short derivation, like, the charging is always 63% of the supply voltage and discharges 37% of the supply voltage. And I hope you liked my video. So if you have liked my video, don't forget to hit the like button and share the video with your friends. Don't forget to subscribe to my channel and press the bell icon so that whenever I post new videos, you will get notified. In the next video, I am going to talk about, basically, I'll be solving some questions on capacitors using all the equations what I have derived. And if you have not checked my previous 2 videos, I strongly recommend you to check my 2 other videos on capacitors, where I have spoken about what is a capacitor, then series and parallel capacitor. And thank you for watching my video. Take care. Bye.